Hello, everyone, and welcome to another Directions Mag Geospatial webinar. Today, sponsored by our friends at Rock Technologies. I'm Barbara Duke, Managing Editor here at Directions Magazine with our assistant webinar producer, Lynette Gualia. If you have any questions about your connection, just drop us a note in the chat. Thank you to the geospatial community for being loyal readers for more than 20 years. We encourage you to stop by often and catch up on the daily geospatial news, articles, and of course, all those webinars. We have the honor of welcoming back our good friend, Jason Harris. He is going to talk with us today about the latest cloud-based trends. I know that is hot on everyone's mind as we are in a very virtual world these days. So Jason, welcome. We're excited to learn more.
Great. Thank you so much, Barbie. Appreciate it. All right. So you probably already figured this out. This is Jason. I'm at Rock Technologies. There's my pretty picture. I'm your friendly GIS nerd that's going to walk you through, GIS in the cloud and some of the current trends that we're seeing, and we think that you should probably keep an eye on too. Here's a quick little about us slide. You guys can look at this. I'm not really here to give you an advertising pitch. In short, this slide pretty much says we know our stuff. We've been doing this a long time. So you can trust us. You can trust us for all your cloud information. All right. Now we're going to get down to the meat of it. This is the agenda, what we're going to do. First, we're going to do a quick review of why you would want to do GIS in the cloud in the first place. We're going to move down to talk about the different VDI solutions, your virtual desktops, and what's new in that space. We're going to then continue down to see, look at some trends that we are seeing. And then lastly, we're going to cover just a little bit on, what we think or what we're seeing as the future of GIS in the cloud. So looking at this slide, I suspect that you're obviously here listening now. This is probably not the first time that you're seeing a graphic like this. You've probably seen this before, and as I look through these bullets, I'm pretty sure that we have hosted an in-depth webinar on each one of these different bullet points. But for the sake of a nice level playing field here for everyone listening, let me do a quick review of why would we want to do GIS in the cloud? What's so good about it? First bullet, let's just start with the scale. And I start with this one because it's probably the easiest to relate to. So, if you're running your, GIS in-house, meaning, down the hall or in the server room or a traditional data center, you really do have a very limited ability to scale. You've probably, if you're like most folks or most organizations, you're on a multi-year hardware refresh cycle. So that means basically at the beginning of your refresh cycle, on day one, you get these brand new servers, and or you scope out all these brand new servers, and you really have to make those decisions right then and there about your future scaling, right? What is my GIS going to look like in year 3? Well, the hardware that I purchase right now in year 1, is that going to be good enough for year 3? Will I have enough hardware to roll out all the new products and the services that are, pretty certain to come as my GIS evolves? If my data requirements increase, am I going to be flying drones this year? Did I plan for enough storage? Did I include extra hardware that's going to allow me to, effectively scale up and meet demand in case of, some type of emergency, when everybody is depending on my public maps and data, when everybody's hitting those applications? I suspect that you can probably already see that, a traditional on-premise GIS has some pretty serious scaling issues that it needs to overcome. So if this was all in the cloud, all of these points are, essentially non-issues. My system in the cloud can scale as needed, from the compute to the storage to bandwidth. I can scale that up without overpaying. I pay for what I use when I need it. I'm certainly not going to be paying for all the extra hardware that I might need in the future, like I would with an on-premise setup. Moving next to the next bullet, this is a biggie, security. It's really my contention that cloud-based systems are inherently more secure than their counterparts that run on-premise. You know, a cloud environment provides extremely fine-grained control. I have the ability to segregate all of these different environments, apply very fine-grained access policies. I can have my disks and all my bandwidth. Everything can be encrypted in transit and at rest. I have firewall rules, you know, all of these things that I have at my fingertips, in addition to the extremely robust logging that I can enable. I can quite literally see every change that's been made to my system. I can look at every packet, every bit of data coming in and out. In short, everything that can be done on premises can be done in the cloud, and often much, much better. That, and don't forget that there's no, I guess, how do you say this, a physical infiltration point, right? Meaning somebody can't drop a USB stick into the back of a server. It's not like you can on premise. Of course, the most important thing about security is to, you know, have that plan in place, have a person or a team that's experienced with the security to have those policies properly in place. Now that's true of on-premise or the cloud, it doesn't matter. Next, control, and this is kind of along the lines of security. You know, a cloud-based system provides you complete and total control over your entire environment. You know, you're not dealing with these physical servers per se. So if a RAID array goes down, or you have bad RAM, or a fan, or a CPU goes bad, whatever, you have complete control over all of those resources, and they're already inherently redundant, right? Next, we've got modernize, and that's sort of an overarching big topic, but it's really easy to relate to this. It's keeping your system up to date, right? Keeping it modern. I still run into plenty of folks that are stuck on, you know, legacy systems for one reason or another, like old hardware, or they're worried about making that upgrade, or maybe they just don't have the resources in-house to do that upgrade. Well, spinning up a development or a testing environment in the cloud is super easy, and it's extremely inexpensive. So let's say, for example, we're looking at a move from 10.6 to the latest, 10.8.1, almost 10.9. That kind of upgrade, that 10.6 to 10.8.1, I can basically smell the fear from all of you GIS admins out there watching. I can smell it from here. But think about it. What if you had that ability to fully test and fully, you know, verify that that upgrade will work in a simple testing environment first? Or what if you had the ability to quickly roll back that update if you needed to? That is all super duper easy to do in a cloud environment, right? Next point, you increase your productivity. This is another kind of all-encompassing one, but you can tell that increased productivity is really a byproduct of all of these different points. You know, now that your system can scale effectively, you have complete control over it, all the resources and the security, you have a modern, up-to-date system that can take advantage of all the latest features, you are inherently more productive. You know, you've streamlined your system, you're getting a better bang for your buck. All of that really equals, in the end, a huge increase in productivity. That leaves us with the last point, and that is better collaboration. And I suspect that is why many of you are here right now. I think it's safe to say that the workplace as we know it has changed forever. So how do we collaborate with our coworkers? How do we work with our data? How do we effectively get our work done? So let's take a little deep dive into this point, as the game has really changed forever. So here we are, it's 2021. I am hosting this webinar from my house in Charleston, South Carolina. There may be a couple of you that are back in the office, but I would be willing to bet that the vast majority of you guys are watching from your own home office. So when this webinar is over, you're going to get back to work. How do you and your coworkers and your employees get back to work? I'm going to be willing to bet that most of you, there is a VPN and a remote desktop connection in your very near future. All of your systems, such as your database servers, your application servers, your file servers, those have traditionally been located in one centralized location, like your office or a data center. But now we are a distributed workforce. We are all over the place. And we really know that is not productive. We are not doing our best work now. You're dealing with latency, slow connections, your maps are drawing slow, you're trying to remote desktop into a VPN into a remote desktop to another machine. Basically, we're still here a year into this, and we're still trying to figure out how to effectively work remotely. I'm here to tell you that it does not have to be this way. How do we fix this? What is the solution? Well, let's put us in a cloud scenario. How do we use our traditional and on-premise desktop clients to interact with our cloud resources, right? The solution is to move those desktops to the cloud too, also. So instead of you going to the client, meaning you schlepping into the office to jump on your work PC in the office, you now bring the client desktop directly to you, no matter where you are. You get it? That's it. That's the solution. You install all of your applications like Pro and Desktop in the cloud, where the CPU and the RAM is cheap, abundant, and you virtualize your applications. So then you simply deliver those desktops with a VDI client. So effectively, all of the heavy lifting is done on the hardware that is running in the cloud. And you're only getting pixels streamed to your local client. You don't need to purchase all those fancy laptops or desktops with high-end specs that you have to use to run Pro now. You can use an old laptop. You can even use a Chromebook if you wanted to. You're accessing that extremely powerful, workstation class PC, and that's all running in the cloud. But the thing is, it feels like it's sitting right there in front of you. You don't feel like you're on a VPN or remote desktop into a faraway server. It feels like your local PC, only faster, right? So what's the takeaway? The takeaway is that you and your workers can always access your data, always access your services, your servers, your software, your applications, no matter where you are, all in one central location. So talking about VDI, that is the virtual desktop that I just spoke about. Let's talk about some things like what's new, what's been happening. I'm going to guess that most of you have used ArcGIS Pro at some point. By now, it really is a modern GIS desktop client that is now fully mature. With all of that new functionality and capability that Pro offers, let's just say we now have some pretty hefty hardware requirements. And one of the most important components that really makes Pro work as it was intended is a GPU, or a graphics card. They're not just for gamers anymore. They're for GIS nerds like myself and you guys. So when you're planning out a virtual desktop deployment for ArcGIS Pro, it is extremely important to include that server-side GPU, right? So all of that being said, the cloud companies that are out there, they are continuing to innovate. They are continuing to bring us these new products. And in this case, what I'm going to talk about are some new instance types, or we can call them servers. This is essentially what they are. And these new servers include dedicated graphics cards that are absolutely fantastic at virtualizing ArcGIS Pro. So in effect, essentially what we're doing is we're taking a big server, we're slicing it up into individual workspaces, right? So for Pro, the basic idea is to pick an instance size or a server size that has a good balance of CPU, RAM, and GPU. So the more instance sizes that we have to choose from, the better, right? you probably guessed that the bigger the server, the more expensive it's going to be, right? So the trick is to find that instance, that server, that is going to check all the boxes without breaking your budget. Because effectively, we're taking that one big server and we're going to slice it up into individual workspaces that all of your team can connect to from anywhere. So that the idea here is the more instances that we have to choose from, the better. So first, let me talk about one that's new from AWS. It's called the G4AD instance. And they're pretty fantastic, I have to say. Very similar to the existing G4 instances that some of you guys may be familiar with. But these new ones, they're using AMD-based CPUs and GPUs. Basically, the end result is that these instances are less expensive. It's basically more competition continues to drive these prices down. And speaking of competition, on the other side, we have Azure from Microsoft, and they do have a new instance family, and it's called the NVV4, and that is also using AMD's CPUs and GPUs. The difference here with the Azure offering is that these instances are giving you kind of a fractional or a slice of a big giant graphics card, and they're just giving you a piece of that for your server. In my mind, these new instances from Azure are really kind of playing catch up a little bit to the elastic GPUs that AWS has had for quite some time, which are also a really great option. But the thing here, the takeaway, more competition, the better. Then let's talk about some of the improvements that we've seen with some of these existing VDI solutions, such as Amazon's Workspaces or AWS AppStream. You know, these solutions are pretty much right out of the box, and they really just work without having to get really too deep in the configuration, right? They're not very complex. You can get up and running really quick. AppStream is one that has come a really long way in particular. You used to just get these individual applications that would stream to you through a browser. Now you have the ability to use a full Windows desktop, right? And it's all purely on demand. So you are literally paying for just the exact amount of time that you're using it. It's very, very, very cost effective. Lastly, I want to mention Citrix, which has really long been the leader in the virtual desktop delivery space. They have continued to innovate, and honestly, their solution, for my money, is really best in class. It's really great stuff. Now, let's talk about some of the trends that we are seeing. You guys are probably seeing this too, but they're just not drones. They're not just a nerd hobby anymore, right? They've become important, and they've become very cost-effective data collectors. Its ability to simply fly a drone up and capture updated, aerials is unparalleled. But of course, with all of that new data coming in, you've got to have somewhere to put it. And I'd be willing to bet that a lot of you watching this right now are asking yourselves that very question: where the heck am I going to put all this data, right? So here's your options. Option one, you can call IT. You'll probably first have to explain to them what LiDAR is, but then you'll ask them, hey, can I get a new 20 terabyte SAN so I can store all of my data? You'll get the outrageous price tag, and you'll probably remember that you're not going to use all of that until year 3 of your refresh cycle anyway, and then you'll probably put your drone program off for another year until you can figure out how to pay for that storage, right? Or you can push all of that data into a cloud-based storage container for literally a fraction of the cost of what that new SAN would cost you. Again, you're only going to pay for what you use, not all that extra capacity that you're waiting to use, right? Just for what you use, and it's that simple. It's almost like cloud storage was invented for GIS. We always want to hold on to all of those uncompressed rasters and point clouds, but we just don't have anywhere to store them. But really, now we do. Here's a quick little sample of how something like this would work. In this example, we're talking about Azure Blob Storage or Amazon's S3. It doesn't really matter. The thing to remember is that these services, these big file buckets, are just endless hard drive space. This is where we're going to put all of our data. This is where we're going to put all of our uncompressed rasters. So next, what we would want to do is to be able to utilize that imagery, we would create a mosaic data set on our file server. This file server will be in our office or in the cloud with, right next to your brand new virtualized desktop. So in this mosaic, we would use a simple cloud storage connection to add those raw images to that mosaic data set. We can add all of our uncompressed imagery to this new mosaic that is sitting locally on the file server. Size doesn't matter, gigabytes, terabytes, doesn't matter. So then we would build our, so then when you basically have your uncompressed imagery or data sitting in these big cloud buckets, and then locally, you're going to want to build your mosaic data sets and overviews. And that mosaic data set will point to the big storage bucket. So for the vast majority of the time, when you're looking at your maps, you're going to be viewing those original, you're going to be looking at the overviews, right? Those optimized raster formats are smart enough. So right when you get down to that one-to-one raster resolution, that's when you have to go and call out and grab data from that big giant bucket. And these new cloud optimized raster formats are smart enough to just grab that little bit that you need. It's really fantastic. It's extremely inexpensive. I think we're talking like $25 for a month of storage, like per terabyte. That's incredible. Next, we have Kubernetes, and I know we're almost out of time, so I'm going to run through this really, really quick. This is probably undeniably the future of Arcgis Enterprise. Before we do, let's just dig into a couple of real quick diagrams of what today's Arcgis Enterprise looks like. I would suspect this looks familiar. This is a pretty typical, highly available Arcgis server site, right? There's all sorts of components, lots of stuff running here, lots of things to configure. We're not even talking about portal or data store or GeoVent, but maybe if we added raster analytics, all right, you can see this is getting very complicated. It's distributed processing, more application roles, more storage options. There's lots more of everything. That's a lot to manage and keep track of, right? So Kubernetes, wouldn't it be a lot nicer if we could just deploy and manage this one thing? And that's really the goal of Kubernetes. It's commonly referred to as like a container. So instead of servers and network load balancers to manage, we have this one simple container. Now, yes, it is true that there are lots of things that make up this container, but the idea is that we have this, with this container, we have a more holistic view of the Arcgis Enterprise. And it gives us these things like built-in redundancy and load balancing and auto scaling and self-healing. We were lucky enough to be invited to work with some of the initial private betas about a year ago. So we've had our hands on this for quite some time. And I'm really happy to report that the results are promising. Obviously, I can't cover all the aspects of containerization in Kubernetes, but just suffice to say, it's some really good stuff. And it's been around for quite some time, but it is brand new to Arcgis Enterprise. So that means that there's a lot of IT folks that are going to need to get up to speed. There's a lot to learn. So it's going to take a little time for something like this to be fully ready for prime time, but definitely keep your eyes on this. It really, really has some amazing potential. And that was it. That was really quick. I'm sorry if I talked super fast. I had a lot to cover. Believe it, you should have seen it before I cut a lot of the fluff out. So thanks very much. I really would encourage you to send questions. I love talking about this. I could talk nerd all day. So please feel free. Drop us a line.
Thanks, Jason. So folks, do make a note of his address there. He's generally giving you direct access to his email. So if you have further questions beyond the webinar, be sure and reach out to him. Thanks again, Jason, for stopping by and talking cloud with us. Reminder to everyone to keep an eye on your inbox. We'll be in touch with the recording as well as any additional information and an attendance certificate. And we hope to see you again at another geospatial webinar very soon. Go make it a great day. Tell a friend about Rock and Directions Mag.